Right, I'm going to use trig ratios to solve things slightly more complicated than just a simple right-angled triangle. So we've got a slightly more complicated shape here, which is this. That touches at right angles. We're given some information here. I'll put the information in red, I guess. We're given that distance there is 20 centimeters. And we're given that the vertical altitude here, this distance here, is 12. We're given that that angle there is 61 degrees. And this thing here, we've got to find theta. Find theta from this information. And it's not immediately obvious how to do this, because the only angle we've got here is 61. And basically, yeah, basically this 61 degrees doesn't touch this angle theta here. There's no sort of connection, except via this vertical line here. So what I'm going to do, I'm going to look at just this, I'm outlining it in blue now, just this left triangle here, just this one here, and I'm going to see if what I can say about that triangle, and hopefully I can work out what some of these other sides are. Before I go on, I'm just going to spend a little bit of time thinking about this triangle here. This is the kind of typical type problem that you get. The crucial problem is we don't know where this point here is. We know this angle here, and we know all these things here, but we don't know where that is. We know it intersects here at right angles, but we need to find this distance here. Or actually, we need to find this distance here. But if we find this distance here, then that helps us to find that one there. So we'll just have a think about that. How do we do this? Okay, well, what I'm going to do is I'm going to take the triangle here that I've outlined here, this one here, and I'm just going to write it out again. And you'll notice that's 61 degrees. This is 12 here, and I'm going to call that x. And then I'm going to remind you that tan 61 degrees equals, well, what's the mnemonic? Sine is opposite over hypotenuse, cosine. Oops, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. So tan is opposite over adjacent, and if you look at this, that's 12 over x. So 12 over x equals tan 61 degrees, and therefore we can take the reciprocal of these guys, and we've got x over 12, just taking a reciprocal, equals 1 over tan 61 degrees, which equals the cotangent of 61 degrees. So let's see if I can work out what these things are here. Where's my calculator? There it is. If I go 61 degrees, it's already in degrees. You see here I could do radians. I'll come to radians later. We'll come to radians later. We haven't got a cot on this calculator here, but we do have a tangent, which is that 1.804, and then we need to take the reciprocal of that to get the cotangent. Reciprocal, where's that? Oh, there it is. 0.554. 0.554, and that equals x over 12. So x equals 12 times 0.554. Do you see why I needed to take the reciprocal between here and here? Because now I just need to multiply both sides of this equation here by 12, and then I've just got my x. Go back to my calculator. So I've got that's already the cotangent of 61. It's got more decimal places here, so you just have to multiply that by 12, and that's 6.65 roughly. 6.65. So x from up here is equal to 6.65. So that helps us, because in this overall diagram here, we know that that's 6.65. So I'm just going to draw it again. Here's my triangle. It's not perfectly drawn, but there you go. That was 12. That was the right angle. This one here is 61 degrees. The whole distance here was 20, I think. But this distance here we've just worked out is 6.65. So now we can work out this distance here, which is going to be 20 minus 6.65, which is 13. I think. Yeah, I'll add the 6.65 onto it. Get back to 20, that's right. So this distance here is 13.35. Remember, we're trying to find that angle theta there. So now what we do is now we think about just this blue triangle on the right hand side here. There it is. First step is to translate it into standard notation. So I've got my triangle which is like that. That should be black, shouldn't it? I've got my triangle which is like that. So I'm just going to flip it over and consider. No, I'm not. I'm going to flip it over. I'm going to flip it over and consider it in standard format like that. So it's just the same. It's just this blue triangle here, this triangle here, but now theta's on that side there because I've effectively taken a mirror image. So now we've got 12, and this distance here is this one here, which is 13.35. I've not drawn it particularly accurately. So what do we know about this? Well, again, we know that tan theta equals opposite over adjacent. Notice how I'm writing it out again. I'll keep on writing them out. Sine theta equals opposite over hypotenuse. I write it out again and again and again and again. Okay, so in this case, so that's the general relationship, tan theta equals opposite over adjacent. So in this case, we've got tan theta, which is unknown, equals 12 over 13.35. Okay, so let's have a look at that. Where's my calculator? There it is. 12 divided by 13.35 equals 0.8988764 or whatever. So I'm just going to do it to two decimal places. That's 0.9 really. 0.90. So tan theta equals 0.9. So theta equals, we need to take the arc tangent of that, like we talked about a few screencasts ago. How do I do an inverse tan? Inverse. Oh no! Oh, it's there. Oh, everything changes. Look, all the buttons change. Do 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 do. Tan, and that's 40. Gone. And that's 41.95 degrees. 41.95 degrees. Problem solved. So let's just go through this whole method again. Let's just zoom in on that. That was what we were given. We were given this angle of 61 degrees here. We were given a couple of distances, and we had to work out that angle theta there. And so what we did is we considered just that triangle, this one here, to get that angle, that distance there. Then we considered that there to get that distance there, and then we used the tangent, arc tangent, to get that angle in there and found the answer. Okay, I'm going to stop there.